Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Nass. I am with Open Systems Media. My guest this week is Carlos Morales. He is the Vice President of AI at Ambiq. How you doing, Carlos?
Doing well. How are you?
I'm doing great. Thank you very much. Vice President of AI. Is that a newly made up title? AI isn't that new.
No, no. I was hired as VP of AI, and with all that entails, 4 years ago, Ambiq was starting down this. It's always been about intelligence at the edge, but we were starting to incorporate AI. So they needed somebody who had done it for a while. Previously, I'd worked on semiconductors for AI acceleration, so it was a good fit.
Okay. So we want to talk about AI at the edge here, and you guys are well known for doing super low power. So I want to get into how much you can actually do at the edge with a battery. So that's the first question. How much can a designer expect to get out of his AI design on a coin cell when you're looking at a battery?
Right. Oh, a surprising amount of AI can be done using a battery, especially if you have something like a 10x power advantage, right? Uh, I would say that um, basically anything that isn't computer vision today can be done for. In fact, I take that back. Even with computer vision, which is probably the most complex kind of AI that we look at day to day, you can do it using battery power. Um, the problem is right now, the way that the market talks about AI, when they say AI, they mean Gen AI. They just mean talking to something and having it respond and respond in iambic pentameter and stuff like that, which is not what we do. Like that's not what we use or Edge AI in general does, right? What we
When you say we, are you referring to Ambiq? You're referring to the industry.
Ambic, but also the edge industry. Now, there's another bit of problem here, right? What is the edge? Where does the edge start and stop? And the edge has really grown to be everything from a laptop all the way out to like the Christmas lights on your tree. And so that also creates some confusion. So we like to say that edge AI is AI that's battery powered, that runs on something like body worn AI or industrial AI, not a smartphone, not a laptop. That is also, the industry still calls that edge AI, but we're beyond that. We're near the endpoints.
That's actually a very good point because, I usually start the conversation with that because for a lot of the people we deal with, it's actually back one step further, where the edge is an edge computer that's within a building. But I know when I'm talking to you, we're generally discussing the edge as being the endpoint, which I think is really cool. It is the sensor itself that is doing the AI. So let's get into that a little more. Some of these algorithms are really complex. Are we running those complex algorithms at the endpoint? And I'm going to use the term endpoint as opposed to edge. So we're talking about the same thing.
Okay.
Is it possible to run those algorithms at the endpoint?
I mean, absolutely. The stuff that we run at the edge, sometimes there's some stuff that I can't talk about because it's customer stuff. But my mind is blown once a week at least, right? You can do anything from detecting if someone has incipient dementia just by listening to their voice on your device. So your ring or maybe a little wristband or something is listening to your voice, not understanding what you're saying. It doesn't understand the words. It just understands how you say it. And you can use neural networks to detect whether that is normal speech or is there some kind of dementia creeping in. Same thing goes for like we all have fitness trackers on our watches these days. Well, these fitness trackers can tell you if your gait is wrong. Like, are you favoring one foot? Are you shuffling? So we're taking those that already uses AI. Like, are you running? Are you going upstairs? That's already AI. We're taking that one step further and like, are you running well? And a lot of our customers, if you buy our customers' devices, they will tell you if you're running well.
Do you feel like this is something that's specific to Ambiq, or is this an industry thing that's happening?
I think the industry is being forced into AI because of the higher accuracy and the greater features that you can do with neural networks versus traditional kind of DSP math. Um, but before, that's always been there. This isn't something new. You just couldn't do it because your battery would run out in the day, right? Sorry, you wish it would last a day, right? Your battery would run out in an hour or two. And we've seen some products that run into that 2 hour limit. It's not a viable product.
What is
With
acceptable?
our customers
And
shoot for weeks. So when I
that's
talk
not
to
what I
what,
asked you. What is acceptable?
well, a lot of people will deal with a day or two, like on something like an Apple Watch and charge it every day. Um, so imagine that you are shooting for a day or two. You can do 10 times more AI in that day or two. Or you could, do really good AI for 10 days. Right? It's really, now we give our customers that choice. Whereas before, it just wasn't possible.
Yeah, and that's really what the point of my question about being acceptable. You can have it run for many weeks if you're limiting the functionality. But if you want this really advanced functionality, you move the window in,
Right.
and there's a different window for acceptable. And if I'm getting the things that you're talking about, I'm okay with 48 hours. I don't think it one day, but 2 days I'm good with.
I think for body worn stuff, that makes perfect sense. People will charge it more often to do crazier things. And a really good example is hearing aids. Hearing aids, people are used to charging them every night. Now, if you can cram some of the stuff that we're putting in hearing aids, like the background noise cancellation, like acoustic scene detection, where it knows, oh, you're in the train station, your acoustics are different from being in a restaurant, and it'll change the equalization using AI. So that stuff, yeah, because batteries are so small, rings come to mind as well. Very, very small batteries. You have to use compute sparingly, unless you're Ambiq. And then there was an old Doritos commercial that said, "Eat all the chips, we'll make more." And that's how we feel. That use all the power. You're okay. We have it in spades.
Are you guys in rings?
We are in rings. Yeah.
Okay. You were not in the ring that I took apart, and I have to say, the functionality was great, but it was too big and clunky. And I've been wearing the same ring for 35 years now, and to have that other ring, which was significantly larger than my wedding ring, it just bothered me. And I like to wear it overnight when I'm sleeping because it doesn't really help you, but I found it very interesting. But it was bothersome because you could feel it amongst your other fingers.
Yeah, and this is a problem for the smart ring industry, and they are all
Mhm.
rushing to solve it. And one of the ways you solve it is by smaller batteries. And guess who benefits from that?
Okay. Um, what are some of the other things that you deem as
While
being
we're on the subject
crazy?
of ring, there's something counterintuitive that happens, and it also
Sure.
happens for cameras and everything, which is the rings are basically just sensors, right? They're
Mhm.
censoring uh, actually pretty sophisticated data that's coming off your
Mhm.
body. And without AI, which is how most rings started, they would send the data raw. Now that, RF is something that's just Shannon's law. You can't get around it. So you're going to spend a certain amount of energy sending data. And
Mhm.
even with Bluetooth Low Energy, which is very efficient, you're still blowing a lot of your battery budget on that. My sales job, sales head of VP is basically an engineering job, and we do a lot of convincing customers. Part of my sales job has been to convince people, no, with our lower power, spend it on algorithms, do the analytics on the ring, and instead of sending a steady stream of heart rate data, you send, hey, here's your heart rate every second. And you not only increase kind of the customer experience because now you're getting constant heart rate, you are saving power. Your battery life is extending, and you can have a smaller battery. So
That
it's
sounds
what's
to me like a memory problem, though, because now you need more memory, and those guys are not as size efficient as you are.
So you have to buffer that memory anyway, right? You don't transmit continuously. So that memory is being buffered. It's only 2 or 3 seconds that you need to do the heart rate. And it's not minutes.
That's really interesting. Yeah, and it makes perfect sense. I would think that's a pretty easy sell to somebody.
You have to convince them that 20 years of, oh, we can't do that, algorithms use power, that conventional knowledge is just kind of built into your embedded DNA is no longer valid.
Okay. Um, you mentioned other crazy things. I know there's only so much you could talk about, but we certainly don't need to mention any customers' names. What are some of these other applications that we'd be looking at over the next year or so?
It's what really excites me is that there's so much creativity, things that you would never, again, you're running AI, you have to create this library of models. You think about the most popular ones and you make those. And then somebody comes, like, I'm going to change the story a little bit, but someone comes up with, hey, I want to stick a microphone on a palm tree and figure out whether that date palm is healthy or not using AI. And you would have never thought of that, right? That's crazy. And the fact that the tools are so powerful nowadays makes it so that it's not some kind of crazy idea some grad student had. It's something that you can productize.
Is the technology too complex to just throw it out there and say, what can you do with this?
That's a great question. It can be. There are, for example, in our devices, there's something called the vector engine. It's similar to on a Xeon, the AVX 512 instructions, but it's ARM's version. And if you just use them, you'll get pretty good performance. If you become a super expert and like a Helium MVE ninja, you will get extreme performance. We're getting crazy results, but it is hard to do. And so what we've done is we've recognized those kind of hard spots and we've created tools to make that part easier.
Yeah, that's sort of my next question. When you're with customers, how much of what is traditionally their job are you doing for them?
So that's a great question. I wrestle with it all the time. Our customers consider their algorithms, many of them consider their algorithms their crown jewels. That's where they add value. When you talk to an ECG customer or a hearing aid customer, that special equalization, all that how they detect your heart condition, that's their crown jewels. My team just makes that thing that they wrote faster. It makes it easier to deploy to the device, makes it faster, makes it smaller, so you can have a smaller footprint.
Cool. Very good. This is really interesting. I'm sure we could talk about this for a long, long time, but we are up against our time. So we're going to cut it off here. And I look forward to some really cool things from you and your team and your customers. I thank you, Carlos.
All right, thank you.
That was Carlos Morales. He is the Vice President of AI for Ambiq, and I am Rich Nass with Open Systems Media.